Okay, so I'd like to begin welcoming everybody to the method seminar. These method seminars are organised between the Danube University here in Austria, the Chef Centre for Health Services Research at UNTH and RTI International, which is in Raleigh, North Carolina. And of course, we welcome individuals from other organisations to attend. Before I introduce today's presenter, I'd like to remind everybody that we're all tuned in using phones or headsets. So if you need to speak with somebody else or get loud wherever you are, then please mute your microphone so we don't disturb the group. I'd also like to remind everybody that we do record these seminars and publish them as slides up on our website. However, we do not record this discussion afterwards. So today's method seminar is given by Byron Wallace from the Centre of Evidence-Based Medicine at Brown University. Byron is an assistant research professor in the Department of Health Services, Policy and Practice, and he's also affiliated with the Brown Laboratory for Linguistic Processing in the Department of Computer Science. His research is in machine learning data mining and natural language processing, with an emphasis on applications in health. He completed his PhD in computer sciences at Tufts, where he was awarded the Tufts Outstanding Graduate Researcher at the doctorate level in 2012. Congratulations. His thesis was on machine learning in health informatics. Thanks so much for being with us today, Byron, and I'm looking forward to your presentation. I'll turn it to you.
Thanks very much for the introduction, and hi everyone. I hope everyone made their way okay. Let's see. Okay. So now I should be the presenter. Can everybody see my my screen?
Yeah, we can all see it.
Actually, let me see something. So I have two screens here, and I'm trying to figure out which one it's showing you.
I'm seeing a background of green.
I just plugged in my headphones and I'm listening on my computer because I couldn't figure out the number either.
Huh. Yeah, I'm getting a little bit of feedback as well, but
yeah, I don't know. I think it's a number in Austria.
Does anyone else want to chime in?
Yeah, I didn't see it anywhere. There was, if you've got the thing on the right open, there's a radio button that says telephone or mic and speakers.
Right. Okay, did we lose everyone there?
You see it?
Okay, so is everyone okay with the sound now? Mine seems to have improved just a bit.
I can hear you perfectly, Byron.
Well, maybe I'll just try and go forward. Okay, so this is so let me tell you a little bit about myself. So my background's in computer science, but I've been working on problems related to helping deal with sort of the information overload in systematic reviews and in health more generally for a number of years now. And what I'll be presenting today is just this tool that we've developed as part of this work that's meant to facilitate citation screening or abstract screening for systematic reviews. So I think you should probably be able to see my browser window here that's showing Abstrack R. So this is the login phase. Can everybody see that?
We see that.
Can you see that? So I think I'm sharing the right screen here. Do you see a screen that says Abstrack R?
Yes, we do.
All right, great. So this is how the login screen looks. Not terribly exciting. So I'm just going to go ahead and log in here. And this is sort of the home screen that you would see. This tool is only for doing citation screening, so it's pretty straightforward because it's really only got one main purpose. So what I'm seeing here is I'm showing the 3 reviews that this user, this Byron user, has started. So I can start screening for any of those, but I'm not going to do that. I'm going to go ahead and start a new project to show you how that might work. So what I'm going to do is I'm going to click on this My Projects tab, and this is showing me existing projects, but I'll go ahead and I'll start a new project. And to do this, I'm going to have to import some citations. So we support a number of importation options, including PubMed lists and RIS formatted files that you can get from, for example, EndNote, and also some specific kinds of XML files. In this case, I'll just go to PubMed, and what I'm going to do is I'm going to just do a search. Maybe I'll search for vampires because who knows. This will show me my results, and I can go ahead and I can export these to a file, and I'll export them to a PubMed list. I'll download this, and there it is. And then I'm just going to go to Choose File. That was in my downloads. Here's the result. I'll call this Demo. There are a number of things that you can set here. For example, do you want the screening mode to be single or double? In other words, do you want everyone to screen articles twice, or do you want, do you want all articles to be screened twice, or do you want, or would you prefer that things are only screened once? So I'll set it to single screen. Abstract R will also actually order the abstracts that you screen in order of their likelihood of being relevant according to a machine learning model. So we can just leave that as is. You can set a pilot round. So a pilot round refers to a set of abstracts that will be screened by everyone. So for example, if you want everyone to screen the first same 100 abstracts so that you can assess agreement, you can go ahead and set this to 100 here, for example. There are these things called tags. So users are allowed to tag articles with arbitrary and personalized tags. For example, they might want to tag things as being, randomized control trials or dealing with children or something like this. So you can do that, and these tags can then be made private, so only shown to the users that gave the tags, or they can be made public so that everybody can see them. I'll leave them as private here. And we'll ignore the other options for now. These are documented elsewhere. So I'll go ahead and I'll say create a new review. And that's going to upload that list of PubMed articles. So there were 62 of them, the ones that I just searched for and found in PubMed. And now what we can do is we can go ahead and we can invite other reviewers. So I don't have anyone else that I want to invite, but if I wanted to, I could either enter their emails directly here. So, you could enter my email address, for example, and send it, or you can send them this link directly. This link is uniquely specifying your review through this string here. So those are the two options. You can always invite people later too. You don't have to do it right away. But from here, I'm going to say, okay, go to my home screen, and what we see is we see that demo that I just created, and we can go ahead and we can start screening. So this is really the main interface of the tool. What this is showing is the title, the journal, the authors, and the abstract. Unfortunately, in this case, there is no abstract. Then what you can do is you can screen out or reject the citation by clicking this red button, or you can say maybe or I don't know with this question mark, or you can screen it in with this green button. So for example, if we screen this one out, it will go ahead and retrieve the next citation to screen, right? So here again we have no abstract. I guess the articles on vampires tend not to have abstracts for some reason. I'll go ahead and reject it again. Okay, so here's one with an abstract. And so for example, we might want to highlight some words in this abstract. So maybe we're interested in articles that contain the word evolution. So I can go ahead and put this term, evolution, into this box. And this is a nice just user interface element. If you do this and you press the thumbs up button, what that's going to do is it's going to highlight all instances of the word evolution, right? And it will do that subsequently for all future review, for all future studies as well. Okay, so that's just a visual aid to help you maybe decide on whether or not something is relevant more rapidly. You can also mark words as being negative. So in other words, these might indicate that something is irrelevant. So I don't know, maybe we don't like bats. So we can go ahead and give this the thumbs down. And subsequently, all words that all instances of bats will be highlighted red, right? Now we can also, like I said, add tags. So for example, we might say, bats here. That would be a little redundant, but we could say bats here. And we can tag it as such. And this will just be recorded and added to that study. And this can be useful for once you've finished screening, you can kind of filter out the citations and find those that you tagged as, for example, bats. Perhaps this is useful down the road. It also shows the mesh terms here under the keywords and the IDs when available. Okay, so that's really the basic setup. Mostly this is what the interaction process is like for the individual user. And you can kind of keep screening. It tells you how many you have left. And that's really it. You can review the labels that you've given. So you see I screened a bunch out so far. And you can actually say, oh, you know what, I made a mistake on this guy. And you can come back to that citation. It tells you that you labeled it irrelevant. You can change your mind. And now it's labeled relevant. And then you can get back to screening if you want. So that's really the basic setup. You can also review your terms. Remember we put evolution in bats, and these will subsequently be highlighted. We can delete these or relabel them as well. So that's kind of the basic screening setup. Now if I go back and I go to the demo project page, it will show me who's involved with the project, how many things they've screened, and so if there were additional reviewers other than just me, for example, you would see those people here, and you'd see how many articles they'd screened relative to me. So that's one sort of feature. You can also go to the project page, and you can actually export labels. So for example, here's again the demo. What we can do is we can export sort of whatever we're interested in. So maybe we want the title. We can also export the tags if we want. I'll just export the title here. And this will go ahead and generate a file, a CSV that you can open in Excel. And here we go. This is showing us the things that we've screened. So these 5 citations. We see the IDs, which in this case are just the PubMed IDs. And we see the title. We see what I'm calling a consensus label. And this basically follows the rule that if 2 or more people have labeled something and they agree, so for example, they both give it -1, which means exclude, then that would be that consensus label, right? But if people disagree, then it will be marked as an O, which means missing. So it's considered missing in this case because there's only one label. So that's just been convenient for some people that use multiple reviewers. But here we see all of the labels that I gave to each of the screen citations. And we could have also exported that tag if I had wanted, and that would have showed up as an additional column. And it will also tell you which of the citations that have not yet been screened by anyone. So that's what this is showing here. So that's really the basic setup. That kind of covers the really basic functionality. You can also do things like review conflicts. So for example, if multiple people have screened an article, an abstract, and they've disagreed, it will show you those citations for which they disagreed, and you can resolve those conflicts, basically. There's a similar thing where you can review maybes. In this case, there were no maybes, so it's telling me there's nothing to see here. So maybes would be cases where you use that question mark and said, I'm really not sure about this one. And then that allows you to come back to those instances. So just to show you some other functionality, let me sign into my colleague's account because he has some, I'm really a computer scientist. I don't really do screening as such. I only build the tools to help you all. But my colleague has a number of very large projects on Abstract R, and I want to show you this one piece of functionality that we allow for. In particular, Abstract R will make predictions for you regarding the remaining unscreened citations. So for example, here is this project called IPD meta-analysis methods. And if I go over to this predictions button and I click on it, what that's going to show me is it's going to show me that it thinks that out of the 170 or so citations that have not been screened yet, only about 16 of those are probably relevant according to the machine learning model. And this is showing a breakdown or a histogram of the predicted probabilities of inclusion for the remaining 170 or so citations. And I can download these predictions, and what this is going to show me is it's going to show me the unlabeled citations and the predicted probability that those are going to be relevant to my systematic review, going to be included. And what we see is there's a large number down here that are screened out by the model. So this is one way of interfacing with our machine learning technologies that we've developed, where if you're so inclined, you could trust these predictions and not bother to look at citations that have been screened out by the computer. So that's a kind of a cool piece of functionality that uses the machine learning approaches that we've been working on over the years. Okay, so I'll sign back into my account. You know, that pretty much covers the basic functionality. I think what I would like to do is I'd like to really see if anybody, you know, what you all would like to hear more about, whether it be the tool and its functionality or other things I can tell you or talk about with respect to the machine learning approaches. I'd be happy to kind of open the floor and let you all lead the discussion.
Thanks so much for that presentation. I have so many questions, but I will hand over to anybody else. Are there any questions from our listeners? I can't believe this. Can you guys hear me? Unmute them all. Unmute them all.
Okay. So
Byron, can you hear me?
I can hear you. I can hear you a bit. It's not too clear. But I can hear you a bit.
I don't know. We seem to have had some kind of microphone problem since the last time we did this a couple of weeks ago. What I actually wanted to do was ask if anybody else had questions before I started bombarding you.
Excellent.
But nobody else is replying to me. Can you ask me?
I wonder if it's not the sound.
Okay, maybe I'll start with my first question then. So when you were exporting new references out, you were exporting them as a comma separated, whatever it's called, variable or something file, CSV.
That's right.
Can you export them back into EndNote?
Okay, I'm sorry, can you export them back into what?
Yeah, EndNote, so that we would have, because when we make our Prisma, for example, at the end of our project, we need to have the includes and excludes coding back into EndNote.
Okay. So that's not something we currently explicitly support, but that could be something that it might not be a huge deal to implement. That might be worth looking into for us. But at present, we don't explicitly support that. You would have to basically, I think EndNote does support importing lists of PubMeds. Is that right?
Yeah.
So in theory, if you exported the PubMed IDs, if you had them, then you can import that probably directly into EndNote. I don't know if EndNote will import for you like a CSV file. It might. I've never tried, but that would be another option. But we don't explicitly export to like the EndNote XML format.
Okay. And speaking of IDs, So it shows the PubMed ID.
Yes.
Have you thought about trying to work with clinical trial identification numbers and, for example, trying to link multiple abstracts from the same trial?
That would be, so you mean like use the clinical trials, like trial identifier as an ID,
Right.
We haven't thought about that, but that would that be useful to you? I mean, it would be interesting. We haven't thought about doing that, but I wouldn't be opposed to it.
Yeah, it would be useful for us because we look basically on the kind of trial level, and often there'll be multiple abstracts on the same trial, but basically inclusion-exclusion criteria is probably going to be more at the trial level. So if I can look at 5 abstracts and they're all from the one like a test trial or whatever, then I can pretty much say you're all in or you're all out because I know this trial.
Okay, yeah, that would be relatively easy. I think it would be relatively easy to implement because I think you can get that information from PubMed directly. But we don't do it currently, but it's something that we would be willing to investigate. I should have mentioned, by the way, I didn't say this. This whole tool is totally open source. So we have this, it's up on our GitHub. There are several people that run their own versions. There are several groups. And this is nice from everyone's perspective because, you know, we're just, I mean, we support it as best we can. But we definitely encourage community adoption, especially if you have some level of expertise in-house. It's not that hard to set up, and if you have your own local instance, that means everything is just local to you, and you can tweak things too if you have anybody with any sort of developer expertise. So I should just mention that.
Yeah, I think we're a little out of that depth. But no, theoretically, I think that's really cool. Let me think about another question I had. So why did you decide to limit it just to abstracts and not include the full text review page as well?
Yeah, it's interesting you asked that. So this is mostly because it's historically been a pain to try to deal with full text, just logistically. So like parsing PDFs is a tricky thing, actually, surprisingly. We're very recently, though, working on just what you've suggested, which is something more toward facilitating data extraction of full text articles. But it's very much in the works and not quite mature yet.
And those predicted probabilities that you came up with there, what are they based on? Are they based on like just the words that come up or the order of the words?
Yes, exactly. So the idea is that we use what's called TF-IDF, or basically just binary bag of words text encoding, which you basically for every document or for every abstract, you create a very long vector. And the vector has entries that correspond to every word that is present at least, you know, once or twice in the whole corpus, in the whole set of citations. And so then you represent a document, a particular abstract, by flipping the entries corresponding to the words in that abstract to 1, and everything else is 0. So these massive vectors is how we sort of represent things, and then you build your model using this vectorized representation.
Okay. Have you guys done any research into the validity of those probabilities? Have you actually come across checked that?
Yes, we have quite a few sort of papers on doing this, and the probabilities are a more recent thing. We haven't looked as much at those empirically, although we do have a paper on that. We've looked more at the actual predictions, the so-called hard predictions, where it says yes or no. Mm-hmm. And what they tend to do is they tend to be very cautious. So the hard predictions will almost always, in our experience, once you've screened a sufficient number of abstracts, we've designed the algorithm to be very cautious, so it will tend to overestimate the relevance of things. Basically what this means is that you'll get 100% sensitivity, and you can still reduce, you can basically screen out some things that are kind of obviously irrelevant according to the model. And so this is a nice way of reducing the workload without sacrificing the thoroughness or the integrity of the review. And I can point you to some papers that we have evaluating this.
So you could get rid of like maybe 10 or 20% of your abstracts that way, you think?
So, could you say that again?
You could get rid of, let's say, 10 or 20% of your abstracts
Yeah, you can. So it depends on the scenario. We actually find that you can, when you're starting for a new review, you can reduce the workload by as much as 50% actually. But again, it depends on the size of the review. So the bigger the review, the bigger the payoff. So if you have like, you know, let's say you had 10,000 abstracts that you need to screen, so a relatively big review. I think if you screened about 5,000 of those, the system would basically have perfect predictive performance subsequently, again, depending on a number of factors. And in this case, you would save a ton of labor. So we have one article on that showed some work that we did on updating existing systematic reviews. So, you know, you already conducted a review back in 2005 or something, and now you're updating it. And in that case, you have a large training set, what we call a training set, to begin with. In other words, the articles that were screened in and out for the original review. And so if you use those, you can actually reduce the workload by as much as like 70 to 80%, because you're capitalizing on all of this data that you already screened. So it really depends on the scenario. But in general, yeah, so 20% I think would be a pessimistic estimate. I think you could probably reduce it more like 40 to 50.
Yeah, that's interesting actually, because when you said that I was thinking it would be sort of updates, but also let's say something like a Cochrane review or, you know, something like ARC methodology, where really the methodology is pretty much the same, the inclusion and exclusion criteria. So you think the machine could learn from previous reviews that are similar. You know,
right, exactly.
Yeah. Okay. Just ask if anyone else here at Australian University have a question? No? Do you want to ask a question personally? I've been told to ask this question. So who can see the conflicts? Only the project leader or each person with the login?
That's right, only the project lead.
Okay, only the project lead.
The idea was that the people in our center anyways, they tend to kind of get together and go over the conflicts as a group.
Yeah.
And so this was the thinking. So basically, when you provide the so-called consensus label, when you're in the consensus reviewing mode, it's actually like a special user. So it won't be under the project lead's name when you look at the exported labels. It will be under like consensus user or something like that.
Yeah. Okay. And the allocation is random as far as we know. So what we would normally do is we would often allocate like a batch of abstracts to first review by a junior and second by a senior. That means each abstract has been seen at least by one senior. So can you do that manually in Abstract, or is it always random who the two people are?
In terms of who screens what?
Yeah, in terms of the two people who are going to get that particular abstract.
Yeah, that's a good question. We don't have. We've thought about and kind of talked about ways of doing that, but at present, you're not going to have control over that. Yeah, there's no way of saying I want this person to screen this abstract.
Yeah, it could also be relevant, for example, if you're using clinical experts, you wanted one, or if you've got two groups, like two universities, and you wanted to make sure that every abstract was kind of viewed by someone here in Austria and someone in the States.
Yeah.
So there could be like
I can see that being useful.
Categories that you might want to allocate abstracts to first and second. Can I ask another question? Why did you decide to put in the I don't know category?
I'm sorry, one more time?
This I don't know as a choice, why did you include that?
Oh, I see. I guess because that was desired by people at the center mostly. You know, so basically the idea is that sometimes I think when you start screening, maybe you don't know, you want to kind of label some as being borderline, and so you can label them as such. And the idea is that you come back to them and revisit those at a later point when you've better established your inclusion criteria.
Okay, so like you have to make a decision. You can just say like it's like skip. Kind of skipping it.
Yes, I mean, so basically it's set up so that, I mean, otherwise I guess what you could do is just screen it in, but I guess there was desire by the users to say explicitly, mark this as like a borderline case or as like a I don't know case.
Okay, yeah. I'm fascinated by this. how many words do you need to make green for it all to work? Like, is that what it's based on as well? Does that have a strong effect on those probabilities?
The number of words?
Yeah, like that bit when you can put a thumbs up and make them green. Is that
Oh, you don't actually have, no, so we do have a little, so in general the machine learning stuff doesn't even look at those, the things that you label. We have done a little bit of methodological work on building a model, a machine learning model that exploits that kind of information, basically that learns from that in addition to the abstract level labels, but really it just relies on the words that are in abstracts. So we do have a model that does that, but it's really too much of a prototype. It's very slow to converge basically, so we don't really have that live on the server. So the predictions, for example, that it presently generates do not. It does not look at those labels.
Okay. I just have, if no one else pipes up or sends us a little chat message or anything that they have a question, I have one concluding question. And that is, so you've taken this and with the process of abstract reviews, which as you know is one small step within the large kind of taking a whole lot of information and data and turning it into a conclusion, right?
Yep.
Where do you see this technology fitting into the other stages?
Yeah, that's a good question. I'm very keen on pursuing sort of the next steps in the pipeline. I mean, you're exactly right. This was viewed as kind of a low-hanging fruit in the systematic review pipeline in terms of what can be modernized with computational techniques and approaches. And this is just a first step. The next thing that I see as being the obvious target is trying to help semi-automate parts of the extraction process. And so I'm hoping to pursue some work kind of doing that. And that's kind of the next thing that I see as being an attractive target. But other than that, you know, I think there's a lot of room for storing and retrieving the structured data that is extracted for systematic reviews. And I know some people are sort of, I mean, Joseph Lau, for example, in our own group, has started the systematic review data repository. And I know Cochrane is keen on basically putting more structure into their data as well. I think they have a call out for a team to do something like this. So I think that there are movements toward this direction, more structure basically, and I'm happy to see that.
Right, yeah, definitely Cochrane has a thing going on, and there was an article in PLOS Medicine by Julian Elliott and a team from Melbourne about living systematic reviews, which is, I think, a really similar topic. Okay, well, I'll conclude there, and I really want to thank you again. Fascinating topic. We are hopefully going to start using Abstract at some point, or we have, a few of us have, and most of us might. And thank you very much for your time.
Yeah, by all means. Thanks for inviting me to chat with you all, and feel free to shoot me an email at any point.
Will do. Okay, bye-bye.
Bye-bye.